This is the plan for today. I will also want to share some exciting experience and what's the current research topic in our field. So I will share something which just happened in ICRA conference. So that will be just 20 minutes sharing, and hope that you guys could work on your current project and later publish in a good conference or journal. For next week, that will be the final presentation. So far, we have been doing a good job. We learned about robotic vision, and people publish papers in the major conference and journal. Right? Then after that, what's the impact to people? I think this is something we need to think about. So one way to be influential is that some media want to cover your work. That's excellent, exciting, right? And this work, you can imagine that the navigation system for the blind, and we actually talk about the detail in the class when we talk about point cloud and some like surface normal estimation and some pulse estimation for the moving camera, right? We have been talking about this in our class. And the other exciting news is that The Economist, that's kind of the major media, 经济学人. Yeah, maybe you know it from something else, but it's a kind of a major media. And then The Economist share this work to the world. I think that's great. Especially the value, you could think that the value might be not just the money, right? Because the blind community, usually they are not that rich. The population is not as big as some other industry. For example, this is the title will be called YCAN 2.0. Okay, so you could imagine that the physical YCAN has been introduced for a long time and nothing can replace it so far, right? And then this will cover like one of the opportunity to do something more, do something a YCAN cannot do. And you guys have been working on Duckietown, right? And I think this is also an exciting photo. I really want to share this excitement with you. That what you have been doing, the Duckietown, people care about it, okay? And Duckietown will be offered in ETH and University of Montreal, Toyota Institute at Chicago. Also, like some people in Duckietown, they went to Newtonomy, okay? And of course, us. So I think this is definitely a very exciting thing to work on. I hope you feel the same way. So this is just like some photo I try to catch the moment during the conference. You could see some of the yellow dots over there. And there are more and more. University, they want to use Duckietown to teach students autonomy and robotics. And that's great. And actually, in fact, in this summer, we will have a summer school. And then some university, even from Korea, they will send someone to attend this summer school so that we can train the TA to work something from scratch, to do the soldering and assembly. So you may think about what you have learned Duckietown and what's next, right? And then you guys still remember APROTAG in our class. Right? So APROTAG is, well, that's the paper from Ed, okay? And then you can see, you know, those guys, you read their paper, you try to replicate their work, and those guys are in the conference, and you have a chance to share exciting ideas together. I think that's a great thing. And Ed has been also working on some like industry stuff. You know, he's still a professor in Michigan University, and at the same time, he opened a startup company doing self-driving. And this is one scenario about, for example, on the highway, you want to cut into the lane between two cars, and then what's the policy and what you should do to observe or to influence the policy of the car. So should the car slow down and allow you to cut into the lane, or something else, or they accelerate, just refuse to give you the space. Last week, we also talked about the Amazon Picking Challenge, and we actually also meet some people there. That's the team from MIT and Princeton. This is Peter. Peter and I used to work in the SAM lab, and this is Andy. So they published a paper about their approach to do vision, how to recognize object and pause at the same time by deep learning. So maybe some of you have read their paper already. Yeah, and their approach is called multi-view self-supervised deep learning for 6D pause estimation. Okay, so essentially the basic idea is that given that this is the ABB arm, given that like state of the art of those machines, they can give you free pause estimation so that you could see one object in multiple view, okay? And then you could actually stitch the point cloud together from each view so that you get a better point cloud, okay? And later on, some deep learning try to find a cube in 3D, okay? And you could see that this is the gripper, and there is a onboard embedded RGBD camera there. And you may wonder that this design may accrue some of the point cloud, some of the views, but it's not a big problem because the robot can observe from multiple positions, okay? And this work is done primarily by Andy and Peter. Okay. Even more exciting idea is that, so the Amazon Picking Challenge has been held for 2 years, 2015 and 16. And you may think that even the winning teams, they solve some of the problem, but maybe not all, okay? And actually the challenge become more and more difficult every year because people are getting better, right? And then you will have to figure out some way to cope with the new challenges. For example, I'm very sorry, maybe you could not see much on the slide, but let me just read this for you. So previously, Amazon will give you all the objects you want to pick up. So there were 27 for 2015 and like 40 something for 2016. And previously, you know all the 3D model, and you know what the object looks like. And then you also know that you could do the deep learning because you will have time to train the model to recognize those objects, right? But in 2017, 50% of the object will be announced 30 minutes before the competition, okay? And you could imagine that how could you like do everything, maybe do the deep learning training in 30 minutes. Is that possible? So people start to brainstorm like new ideas to solve the new challenge. And the other thing is the storage system, the shelves, they will become smaller and smaller. That means when your gripper get into one of the block, it will be totally occluded. Your vision system will not be able to see anything, okay? Then what can you do with it? So I think this is good things that we are working on the problem, and it's more and more closer and closer to a real situation. Okay, so let me ask you those questions. Now there are two new challenges in this coming Amazon. It's called Robotic Challenge now. And what do you think? How can you solve those problems? So we just talked about like two challenges, right? One is that you won't be able to know what object you want to pick 30 minutes before the challenge. And the second challenge is that the shelf will be very small. There will be lots of occlusions, and your vision system may not work at all because you cannot see anything. I think that's a good question. So previously, there are only like 40 something, right? And then you already know what you want to pick up. And now this year, you won't. Half of them, you don't even know what you want to pick up. But I think you bring up a point that maybe there are a certain amount of product in Amazon warehouse? Anyone want to give an estimation how many products in total in one warehouse? Maybe you can give us a try, like how many products in one warehouse? 100,000. Okay. How about you guys? Jackie, what do you think? How many products in a warehouse? Now we are talking about the scale. So one way is that I just train everything that could happen in a warehouse, right? So give us a number, please. So you can just say 100,000, 1,000 in one warehouse. Tony, give us a number. 300,000. Oh, workers. 300 workers. And how many robots? 2,000. Okay. Okay, yeah, let's see. So now we are talking about scale. Okay, so approximately this is, well, the data is provided from Amazon themselves. They were there. A manager from Amazon Robotics, the guy is in the conference. Okay. About 1,000 workers, 1,000 robots, 10,000 inventory pods, okay, and about 1 million products. So it's about 1 million. So if you want to, maybe you could say, I just use deep learning to train 1 million, all the possible product that could happen in the warehouse. The network may be very large, yes. Yeah, we have been dealing with like 80,000 outputs of a CNN, and that will dramatically increase your weights, the total memory needs, because there's a few layers, they are fully connected, and it will kind of blow up the memory you need. So, okay, the problem is that the space on the shelf, it will become very small. It will maybe just allow your robot arm to put the gripper inside the space and try to grab something. Maybe make a tiny camera on the hand, right? Or how do you think? Yeah, the problem is that the shelf is small and there will be like occlusion when your gripper in the shelf, right? Your vision is essentially, especially if you like mount it there, it's not going to work because there will be lots of occlusion. You are not able to do the multi-view anymore. Okay, what can we do? Yeah, okay, that's one way that your camera can just see all the objects before the gripper is inside. So when we had a dinner together, there is another postdoc from MIT, and they are working something like a touch sensor, like tactile sensor, and it's called GeoSight. So let's take a look. Okay, and that's an interesting idea that also like people start to use tactile sensor on the gripper because eventually you want to solve the problem. And you could see that this could be also a vision problem. There are like different techniques, and this is one of them. And they have a special gel, and they call it GeoSight. And it could actually give you a very, very high resolution. Even your skin, your like wrinkles on your skin. Yeah, and the fibers. Okay, but maybe for Amazon, like it's a little bit overkill, right? But this is one idea. Okay, suppose your vision, your RGBD camera is not working anymore. Maybe you could use tactile. Okay, so this is also one of the active research topic. Okay, and this conference is a little bit different from like the previous conference I have attended. Actually, people start to think, especially how our research work can benefit like entrepreneurship. So they actually have a program about, it's called RIE. Okay, robotics, innovation, and entrepreneurship. Okay, and this is the rule. Industrial leaders will share current real-world needs and their latest developments. Okay, so this is about what people need or what the industry, what's the real scenario. Number 2, up to 4 startups will give a 5-minute pitch of their solutions to the audience. So always you have 5 minutes to show off what you have been doing. And you will have to convince those industry leaders that your solution can help them. Okay? And 3, the panel will select winning pitch for each focus area. So that there will be some guys sitting there and then try to find who is the winner. The winner will get actually no money, but you will be visible. So that there is another keynote. They are doing like a medical robot. They put a tube inside your stomach, and there are 2 small grippers and some lasers that could try to cut out of the cancer skin inside. Okay, they try to do this. And then when they start to develop this technology, they do this. They try to pitch, and then they won the prize, but no money. But eventually, when you increase your visibility and your technology, people will fund you. So here is one of the first keynote in the conference, and talking about the impact academia, media, government, and industry. Okay, so we have talked about the academia a lot, right? So we talk about like how to do your research and solve the problem, right? And then publish a paper. That's and you got lots of citations, and that's the impact on academia. And we also talk about media. Yeah, so media, essentially, they are good people who want to tell good stories and inspire people. Yeah, that's the optimistic side of media. And you could think that suppose your work is covered by media, you also gain some visibility. When we talk about government, you could also think that's good people look for technical input to make good policy decision. This is also important, right? So maybe the government minister of our maybe he's very good at one of the area, but maybe not all of the areas, right? So suppose what you are doing can influence your government to make the right decision. That's great, right? That's something you definitely want to do, okay? For my own experience, I actually attend one of the events. He's the Minister Chen. He actually gathered about 30 young professors, ask what do you think about the policy? Is there anything the government can do to recruit more international talents to make our people want to stay in Taiwan for their career? And how to lots of things. So even that some people will say, maybe Taiwan is not good at AI or something. Yeah, but actually the government need to maybe hear your voice. Yeah, and this is something I just mentioned. So the VC, they want to find brilliant technical teams to fund. Okay, so this is the last slide. This is like a slogan, let's realize our dreams and make the world a better place.